Welcome back to another exciting day in mathematics. Woo, woo. How's everybody doing? Good? All right, warm-up number 116 should come up on your screen. Let's get started, please. And I'm back. They took me away to some training. Yeah. Do I look it? Yeah. Let's go. No, it wasn't that kind of, it was like in here. Yeah, hurry back, please. But anyways, we're just doing trainings and getting everything ready for the testing that's coming up in a couple weeks. So, you know, we had to do what we had to do. Anyways, I'll give you guys some time for that. Ready, go. Copy that, please. All right. What are the three measures of variation? Tell your neighbor, please. What are the three measures of variation? By now, that should be automatic in their noodle. Mario, what are they? Standard deviation, variance, and range. That is correct. All right, so to get our bell curve, we need a mu. Pass someone, Mario. Max. Oh, you just got here, okay. 67.7. 67.7. All right, looks about right. Oh, my bad, my bad. We need a variance. Variance. Let's go with Sante. What'd you get? 356.7. Pretty close. Standard deviation, pass someone. Mel, what'd you get for standard deviation? 18.88. I'll leave it at 18 point. I'm gonna round it up. 18.9. Hands if you got close to that, -1 or +1. Okay. So we are at, let's see, on the top end, we should be 70, 80, 86.6. And on the bottom end, I'm at 48.8. Is that correct? Yes, no, maybe so. Vanya? 76.6 on the mean? Ah. Come on, Max. 76.6. Like that? Yes? All right, so back to the drawing board. 76.6 plus 18.9. That is 96.5. $86, 94, 95.5. Check my math, 95.5. And then on the other side, we are at 50, 40, 48, no, 47.7. 57? 57.7. All right. Pretty close, yes. Range, we get for the range, Aleshka. $50. All right. Send that in, please. Agenda warm-up number 116 done. Discrete probability distributions. Today we're going to be done with that. And tonight's home play, Chapter 5, cumulative review. Let's see how you do with that, being that Friday's coming. Let's go, Aaron. We got this. Oh, yeah. All right, do me a favor, copy the code to access the home plate tonight, HA4KB, HA4KB. Write it down, please. All right, so once again, HA4KB for the home plate. All right, get a Cornell note ready, please. I can define and compute discrete probability distribution. Today we're going to wrap this up. Woo, right on cue with a song, right? We're going to wrap this up. Let's go. I should have started like the crack of the whip, I snap, attack, front to back. That's pretty good, huh, Lulu? Let's go. So discrete probability distribution, today's going to be just a review. I do want to touch on Poisson distribution just for the fact that I sense a disturbance in the force, and I just want to make sure we cover that, make sure we got it, okay? So, we've been here. We already know the difference between classical, empirical, subjective, yes? For the variables, we know the difference between discrete and continuous. From there, we know what probability distributions are. Tell your neighbor once again, remind them what are probability distributions. All right, what is so special about that, David? What's that? He said the probability needs to add up to 1. Bah. Next, from there, I gave you guys mean, variance, and standard deviation for probability distributions. From there, we moved on to binomial distributions. There's a formula. Of course, after that, I gave you guys mean, variance, and standard deviation for binomial distributions. And then from there, we went into multinomial, yes? And then we ended up, after that, with Poisson distribution. I left you guys a video lesson because I was at a training. Talked about the mathematician. His last name was Poisson, hence the formula was given his name. From there, the Greek letter L, which is this one, is known as lambda. Some of you that are heading to colleges that have some Greek, places around there, they're going to be named after Greek letters. So just get used to those letters. This is lambda. The lambda stands for the mean of whatever it is they're talking about. The x is, of course, a specific number. And E gives us the approximation of 2.7183, okay? All right, then in the video I showed you guys this problem, and it was worked out as such. But I do want to elaborate in regards to this portion right here. And some of you somehow skip this step and keep bringing it to the denominator, but let me elaborate on that. So here it goes. Write your utensils down, look up to the screen. I'm going to take you guys back in time to Algebra 1. Here it goes. So in Algebra 1, your teachers, of course, they taught you rule of exponents. Me, I like to present it like this. 3 to the 5th over 3 to the 2nd. Now, if you agree, 3 to the 5th is 3 times 3 times 3 times 3 times 3. Is that correct? 3 to the 2nd is 3 times 3. Yes? So therefore, what is 3 over 3? 1. What is 3 over 3? 1. So basically, it makes a giant 1. Yes? So therefore, what's left on the denominator? 1 times 1 is 1. What's left on the numerator? 1 times 1 times 3 times 3 times 3. That's 3 to the 3rd. Everybody agree with that? 3 to the 3rd, we know it's 27 over 1, which is 27. But then, of course, the way I present it, I'm like, all right, guys, but I don't want to do all this work. I just want to come up with a rule that I see from here that's going to take me to there. Look at it, talk it to your neighbor, and let them know what rule would you come up with to go from here to there. Talk to the neighbor. What do we do? What do we do? All right, looks like Amelia's got it. Very good, Amelia. Looks like Max got it. Very good, Max. I see you. Mel's got it. How about them apples? Mel, what would be our rule? Subtract what? That is correct. We subtract exponents if the base is the same. Since they have the same base, 5 minus 2 becomes 3. That is correct. Okay. Make sense? Yes? All right. Therefore, you do agree that if I do 3 to the second divided by 3 to the fourth, tell your neighbor the answer for that one to skip all the work. What is the answer for that one? Tell your neighbor. Three to the negative 2. Let's see. What is 2 minus 4? Negative 2. Okay. However, look up to the screen. What if I did show the work? 3 times 3. 3 times 3 times 3 times 3. What is 3 over 3? 3 over 3. It makes a giant 1. So on the numerator, 1 times 1 is 1. Denominator, 1 times 1 times 3 times 3 is 3 to the... Whoa, what just happened? What just happened? You're like, well, wait a minute, Mr. Q. So if I use the rule, it's a negative, but if I don't use the rule, it's a reciprocal with a positive exponent. That is correct. That's why, from now on, anytime you see a negative exponent, put that over 1, do the reciprocal, and that makes it 1 over 3 to the positive 2. Or in other words, sending it to the denominator, which brings us to where we are with that formula. Look up. Negative 0.4. Instead of leaving it up on the numerator, we send it where? To the denominator. Why? Because we can't have negative exponents. Let's go. Oh, yeah, we got this. All right, so with that said, yesterday I gave you guys the task by yourself to work on these. Is that correct? Yeah, yesterday. So you did either 1, 2, and 3 or 1, 4, and 5. Is that correct? All right, so together, let's do number 2. So on your paper, copy number 2. Let me send that to your screen. Give me a second. Number 2, copy the entire problem so you can have one complete example on your notes. It is on your screen, and let me read it out loud as you're copying that on your notes. It says, number 2, power outages occur randomly with a mean of 1 outage every 15 weeks. Calculate the probability of experiencing at most 3 outages in 15 weeks. So copy that on your notes, please. I'll wait for you. All right, everybody copied that already? All right. Give some of you a little bit. All right, here we go. Y'all ready? So let's write our formula for Poisson. P of X, semicolon, lambda, and that gives us e to the negative lambda exponent times lambda to the x exponent over x factorial. But what am I talking about? You guys know this by heart now. Very good. All right. So which means what, Mr. Q? Which means on the side I need an x value. In green, I'm going to need lambda. And in red, I'm going to need E approximately, what E is. The easiest one is E, which is 2.7183. Yes, that is correct. Okay. Next, we're going to read the problem and figure out what lambda is to get started, because that's the mean. Is that correct? Lambda is known as the what? Does everybody know what I mean? Mean. All right, it reads, power outages occur randomly with a mean of 1 every 15 weeks. Tell your neighbor how you would write that. How would you write that? Yes, that is correct. 1 over 15. Calculators calculate, or approximately in decimal form, that is point what? 0.67? I'm just going to leave it at 0.06 for right now. All right, now let's go with X. What are they asking us to do? It says calculate the probability of experiencing at most 3 outages. Tell your neighbor what that means. What at most? At most. What does that mean? Talk it over to your neighbor, please. All right, what does that mean, Alessandra? Give me numbers. Yes. Amelia. Santi, go. That is correct. 0, 1, 2, and 3. At most means all the numbers before that number. So what does that mean, Mr. Q? That means that over here, we need P of 0. We need P of 1. We need P of 2. And we need P of 3. Lambda, by now, we know lambda is what? 0.06, 0.06, 0.06, 0.06, 0.06. And then we need to find all those probabilities, and at the end, what do we do with all those probabilities? Add them, yeah. All right, so let's work this one out. I'm going to start with this one so you guys can see the whole mechanics of it. Yeah? Here we go. E. E is 2.7183, 2.7183 to the negative lambda, which is negative 0.06 exponent, times. Now, once again, I'm going over this one just because I sense that some of y'all didn't do the practice. Of course, not in this class. Lambda, again, is 0.06 to the x exponent. What is x? And this one we are at 0 exponent. And let's go to the denominator. X is, again, 0 factorial. Right? That's a jam right there. All right, here we go. At the next step, look up. What do we do with this? Remind your neighbor. What do we do with this negative exponent? What happens to that? Send it to the denominator. That is correct. So I'm going to send it down here, 2.7183. And we change the exponent to a positive 0.06 exponent. Let me finish the denominator. What is 0 factorial? That's a rule. Then Max is going to enlighten us. Tell your neighbor, what is 0 factorial? Remind your neighbor, what is 0 factorial? Max. One, that is correct. So we got this here, we got this here, and what's left on the numerator? 0.06 to the 0 power. Question. Any number to the 0 exponent, tell your neighbor what that is. Any number to the 0 exponent is 1 is correct. Woo! Man. So we end up with 1 over 1 times 2.7183 to the 0.06 power. So on your calculators, type in 2.7183. Then arrow up or caret, and then put 0.06. What is that number? 1.06. And lastly, what is 1 divided by 1.06 approximately? Point what? 0.94 approximately. All right, so we did, this is P of 0. Let's go to P of 1. Now check this out. Once we have the first one set up, look up. We already know what this is, don't we? This is 1.06. So that saves us some time. We just write out numbers. So let's do the next setup. Here it goes. 2.7183 to the negative 0.06 times 0.06, but now it's to the first power, over 1 factorial. So what do we have here? We bring this one down over here, so it's 2.7183 to the 0.06 exponent, times, what is 1 factorial? 1 factorial is 1, Mr. Q, okay. And question, what is 0.06 to the first power? It's still 0.06. So that ends up being 0.06 over, we know what this is, right? 1.06. So that's approximately, Lulu, calculator, 0.06 divided by 1.06. .056, okay. Hands if you got that. All right, looks about right. Okay. So I'm going to give you a head start, do the other two, and then I'll show you the work in a little bit. Go. So here, once again, we have P of 0 is there, P of 1 is there, P of 2 is there, P of 3 is there. From there, we did what? We add them. Yes. And then we end up with that. Yes? You get the idea, yeah? All right. So, with that said, this is tonight's home plate. This has everything we've done with Module 5. So this is what you're going to do right now with your neighbor. You're going to go through numbers 1 and 2 and 3. That shouldn't take you more than 2 to 3 minutes. Because all you have to do is either A, B, C, or D, A, B, C, or D, A, B, C, or D. Numbers 2 is yes or no, yes or no. From there, 4, 5, and 6, you need to know which one is multinomial, which one is a Poisson, and which one is a binomial. So, I'll give you guys some time, and then we'll talk it over in a little bit. Talk it over to your neighbor, please. I'll send that to your screen. And those of you following on YouTube, get some practice in with this. I'm going to stop the video right here. See you guys next time. Peace.